Hello everyone, Mr. Stevens here. Today's lesson is going to be about the surface area of prisms. We're going to talk a little bit about exactly what surface area is as we move on with the lesson, but basically what it's going to be doing is applying what we've learnt about area to three-dimensional shapes. Before we move on though, we'll have a quick revision question. I'd love for you guys to all pause the video here and have a go at this question yourself, and when you come back I'll show you how to do it. Okay, so this is a composite shapes question. We're looking for the shaded area here and here. So we need to find two areas. We need to find the area of the total shape, and then we need to find the area of this triangle to subtract from the area of the total. So we'll find the area of the rectangle first. And remember, our formula for the area of a rectangle is just base times height, which is 18 times 10. So the area of the rectangle is 180 centimeters. And now we need the area of the triangle. And remember, the formula for an area, the area of a triangle, is a half times base times height. And we can fill in these numbers. A half times 18 times 10. So the area of the green shaded triangle is 90 centimeters. Oh, and I've made a mistake here again. I forgot my squares on my units. It's very important that we don't forget those. So now that we know the area of the whole rectangle and the area of the triangle, we can calculate the area of the shaded parts by taking the area of the rectangle and subtracting the area of the triangle. So that will be 180 minus 90, and the answer then is 90 centimeters squared. Okay, moving on now to surface area. What is surface area is the first question we need to answer. So the surface area of a three-dimensional shape is the sum of all the areas of the sides. So we can visualize this with what's called a net, a 2D illustration here. So we have a cube here on the left, and a cube has 6 sides, 6 faces I should say, and each of those faces is a square. So if let's imagine we made a cube out of cardboard or paper or something, and then we cut open some of the sides and laid it out flat. This is what it would look like, the net here. And you would be able to measure the sides of each of these squares and calculate an area for each square. And then the surface area, the area of every face of this cube, would be found by adding up all of these areas of these individual squares. So let's look at some different shapes and how we would unfold them, turn them into nets. This is important. Nets. Think of it like that, the unfolded shape. So if we've got our rectangular prism here, there's a big rectangle on top and a big rectangle on the bottom. So that's these two rectangles here. Then there are a slightly smaller rectangle on each of the sides. So when we unfold them, that's these two shapes. And then we also have the two ends of the rectangular prism, and we see those here. And then this is a formula that we can use but I don't think there's that much benefit to you in memorizing this formula. As long as we can memorize how to turn a rectangular prism into a net, we don't really need this formula because we know how to calculate all the individual rectangles, and we can just calculate them all and add them up to find the surface area, which is what's happening down here in this formula. So when you have a triangular prism here, let's match the sides again with the sides in the net. We've got the base of the triangular prism. The side closest to me is a very large rectangle. That's it here. Then this side here around the back is a slightly smaller rectangle. And then this side here is another rectangle. And then you have the top and the bottom represented by triangles. And again, if we add up the area of all these shapes on our net, we get the surface area. So let's try some examples, and hopefully if that's still confusing, you'll pick it up as we work through some examples. So the first thing we're going to do is we're going to turn our shape into a net. So start with, this is the base of the rectangular prism, what we would see if we were looking up from underneath. And it has a 5 centimeter side there and a 3 centimeter side here. Okay, now coming off the base, we have the sides of the rectangular prism. But they're not quite as wide because they're only 2 centimeters. This side here is only 2 centimeters. And we need one of these on either side of our base. I'm going to take these numbers off for now because it will get a bit confusing as we start to make more sides. Now let's deal with the top and the bottom, sorry, the front and the back of the rectangular prism. They come off the base at the top and the bottom. And the last thing we need to deal with is the top, which can go on either side. It could also go over here. Now that we've got our shape laid out flat, it's important that we get down all the measurements properly. So all of these long lines correspond with the 5 centimeters here. Now there will be some here that are 3s, and these smaller ones in the middle are 2s. And it's important to note that the 2 centimeter side is this one and this one. And the 3 centimeter sides are all of these. So now what I'm going to do is I'm going to go around in purple and I'm going to number each of our shapes here. So now we need to calculate all the areas of these 6 shapes. So what I'm going to start by doing is writing down the formula for the area of a rectangle. And then we're going to start calculating area 1. So area 1 here is the shape that I've put a 1 on. And it's going to be 2 times 5, or 10. Area 2 now is the area for the shape with a 2 on it. And it's going to be 3 times 5 because this shape has a side with a length of 3 here, and a side with a length of 5. Shape 3 is actually the same as shape 1, so we don't have to calculate it again. Sorry, I should be writing units on all of these. And again, shape 4 is the same as shape 2, so we don't have to recalculate that. We've already done it. And now let's do shape 5, which is going to be 2 times 3. And I've kind of run out of room here at the bottom, but we know that 5 and 6 are the same. So we don't have to recalculate 6. We know that it is just 6 centimeters squared. So now what we're going to do is calculate the whole surface area by simply adding up all of our areas. So all we need to do now is fill in our numbers. 10 plus 15 plus 10 plus 15 plus 6 plus 6. So our answer is 62 centimeters squared. That gives us the area of all the sides of this rectangular prism. Let's try again with a triangular prism. It's going to be a little bit more complicated. But again, the first thing we're going to do is draw up our net. I would encourage you to always start with the bottom of the shape. That's this side here with 12 centimeters and 5 centimeters. And then you can just build off it from there. Next, I'm going to include this side, which is attached to the base, with a 3 centimeter long width. And then next we'll do the front side, which is 4 centimeters long. And then now we just have to put the triangle on the top, which is 3 by 4, and the triangle on the bottom, which are both the same. I might just move this 5 centimeters so it's a bit clearer. Right, and again what I'm going to do is number all of my sides. So now we're going to need 2 area formulas for this. Rectangle. And we also need triangle. And then I can just go down the list and calculate all my areas. Area 1 is 3 times 12, 36. Area 2 is now 12 times 5, which is 60. Area 3 is going to be 12 times 4, 48. area 4 is now the triangle, half times 3 times 4, which I've run out of room a little bit. Sorry, I need my calculator for this one. Oh, maybe I didn't. So that equals 6 centimeters squared. And area 4 is the same as area 5. So we don't need to recalculate that. So now we can find the surface area by adding up all our areas. So we've got 36 plus 60 plus 48 plus 6 plus 6. I'm going to put this one in my calculator so I don't make any mistakes. And then we end up with 156 centimeters squared. Okay guys, what everyone is going to do now is head to the EP lesson, which is linked on Outline. Thanks guys.